3-8 unions and intersections of sets. So our objective for this section is to find the union and the intersection of different sets. And our essential understanding is that given two or more sets, you can describe which element belongs to at least one set. You can also describe which elements belong to all of the sets. And we can use different symbols to represent this relationship. So first we have a union. Think of union is when we take two or more sets and we're going to smush them together. Okay, we're going to make a union of the two of them. So the union of two or more sets is the set that contains all elements of the sets. The symbol for union looks kind of like a U. Very convenient. Okay? So to find the union of two sets, list the elements that are either in one set or in both sets. An element that is in the union if it belongs to at least one of the sets. So in the Venn diagram below, A union B is shaded. So you can see that we have all of A, all of B, and the part in between. Okay, the part that's in both. So if we have a number, a thing, anything, any element at all that is in any of this region right here, in part A or part B, then it is going to be inside the union of these two sets. If it's out here in the rest of the universe, okay, then it's not inside the union. So, first problem is the union of sets. In your left pocket, you have a quarter, a paperclip, and a key. In your right pocket, you have a penny, a quarter, a pencil, and a marble. What is the set that represents all the different items in your pocket? Okay, well, so let's write down these sets. So set L is going to be my left pocket, and that's going to equal, remember that inside of a set, we put a little bracket. We have a quarter, a paperclip, and a key. In my right pocket, I have a penny, a quarter, a pencil, and a marble. Okay. Too many things start with P's. Okay? So when I union these two together, when I want to know what I have in both my pockets, I now make a set that has everything. Okay? One important thing, however, is I don't have to put quarter twice. I have a quarter in one in one or the other pocket. I have a paperclip, I have a key, I have a penny. I don't have to write the quarter again. I have a pencil, and I have a marble. Right? And that is the union of all of my sets. Putting the two sets together. Let's try a got it problem. Okay. So this one, we're actually going to use some numbers, make it a little more clear. Okay. So write the sets P and Q in roster form. That means, remember, that we're going to list everything in the set. So set P is X such that X is a whole number less than 5. Well, remember, whole numbers do include 0. So 0, 1, 2, 3, and 4, but not 5 because it says less than and not less than or equal to. Set Q. Y such that Y is an even natural number less than 5. Okay, well, natural numbers do not include 0. And so the even numbers that are less than 5 are going to be 2 and 4. Okay. What is P union Q? Okay. So we're going to take everything in P and everything in Q and put them together. 0, 1, 2, 3, and 4. Okay. We don't need anything else because both 2 and 4 are already in set P. So we didn't even need to add them. So what's true about the union of two distinct sets if one set is the subset of the other? Well, if this is true, if B is a subset of A, remember our notation, then A union B will be the same as A. And you can see that here because Q is a subset of P, right? 2 and 4 are both in P. And we can see that P and P union Q are both the same. All right, so next is intersection. So for intersection, now we're going to see where these two sets cross. Okay, what is common with both of them, where they intersect. Okay, so the intersection of two or more sets is the set of all elements that are common to every set. An element is in the intersections if it belongs to all of the sets. The symbol for intersection is that symbol right there, which is clearly not a U. So that's how I like to tell the difference between intersection and union, is that one, union looks like a U, intersection doesn't look like a U, it's an upside down U. Okay? When you find the intersection of two sets, list only the elements that are in both sets. So in the Venn diagram, you can see that's only this region right here, where they overlap, where they cross. Another vocabulary word is something called disjoint sets. These sets have no elements in common. The intersection of disjoint sets is the empty set. Okay, so you can see that A and B in this diagram right here never intersect. They don't have anything in common. We could find the union of two disjoint sets. It's just everything in A and everything in B. But we can't find the intersection. It is the empty set. Okay. So set X equals X such that X is a natural number less than 19. Set Y is Y such that Y is an odd integer. And set Z is Z such that Z is a multiple of 6. Okay, well, to help us out here, let's first list all of the sets. Never mind, this set is kind of big. Yeah, we can do it. Okay, so X is going to be natural number, so no 0. No other restrictions, so 1, 2, 3, 4, 5. And I'm going to use ellipses to help me out all the way up to 18 and 19. Okay? Set Y is an odd integer. So that's going to be 1, sorry. Odd integer means any negative and any positive number. So we're going to use ellipses like this. And so that's going to be -3, -1, 1, 3, 5, and we keep going. Okay? So set Y goes forever in both directions. Set X is limited in between 1 and 19. Sorry, natural number less than 19, so we're not going to include 19. Whoops. Okay. And set Z is going to be Z such that Z is a multiple of 6. So, multiple of 6, that's going to be 6 times 1, 6 times 2, 6 times 3. So we're going to have 6, 12, 18, 24, and we can keep this going in this pattern like that. All right, so what does X intersect Z? Where does X and Z cross? So we can see that X intersects Z at 6, because 6 is inside this, that's in the ellipse, but also inside there is 12 and 18. What is Y intersects Z? Well, Y intersects Z at only odd numbers. Well, multiples of 6 have no odd numbers because every multiple of 6 is even. So these two never intersect, and they are disjoint. Okay, so let A equal 2, 4, 6, 8, let B equal 0, 2, 5, 7, 8, and C is going to be n such that n is an odd whole number. So let's see if we can figure this out without having to write out set C. A intersects B, nice and easy. Just look at these two, and what do they have in common? Well, they have 2, uh, not a 4, not a 6, and they have an 8. So A intersect B at 2 and 8. A intersects C. A intersects C. Uh, A is 2, 4, 6, 8, and C is an odd whole number. Well, nothing in set A is odd, so they don't intersect anywhere. And C and B, well, the only places that they intersect are 5 and 7. 0 is not odd, 2 is not odd, and 8 is not odd. Okay, so they're not in set C. Okay. So you can draw Venn diagrams to help you solve problems involving relationships between sets. Okay. So, apologize for the pictures here. They might be kind of hard to see, but we can make a Venn diagram to describe this situation. So 3 friends are going camping. The items in each of their backpacks form a set. Which items do all 3 have in common? So let's see if we can make a nice Venn diagram for this. So I'm going to use, oh, hopefully that'll work itself out. There we go. Look at that, how nice. So we got a couple things going on. We got the yellow backpack. Let's put a big circle for that, or an oval. We got the blue backpack. Let's put a big oval for that guy right there. And then we got the red backpack. So let's go something like this. All right. So there's going to be some things that are in both, and then some things that are in all 3. So let's call this one yellow, blue, and red. Okay. So in the yellow bag, we have our sunglasses. We also have some flashlight. Where's the flashlight? There's my flashlight. Now, if you look in between the yellow and the blue, both of them have, well, let's not get to that yet, because we can see that all 3 have a red hat. So that's going to be in all 3 terms. The yellow and the red both have this pan. So that's going to be in just the yellow and the red and not the blue. So the pan goes there. What else do they all have? Oh, look. They all have a bottle of water. Might not have made this big enough, but we'll get the idea here. They all have a map. Okay, so that goes in there as well. And what else are we missing? The blue bag has a first aid kit, and so does the red bag. So in the, let's go back down here again, in the red and the blue, we have first aid. Okay. The red bag has a rope. And the blue bag has this camera. Okay. I'm not sure what else is going on in here. Like I said, it's kind of a hard picture to make out. Luckily, I had the textbook to help me out. But to answer the question, which items do all 3 friends have in common? They all have a hat, they all have some water, and they all have a map. Okay? Hat, water, map. let's look at a guided problem. So, set A is the first 5 letters of the English alphabet. So A is going to be A, B, C, D, or E. B is a vowel. So set B is going to be A, E, I, O, or U. We're not going to include Y, right? A, E, I, O, or U. And set C is a letter in the word vegetable. So V, E, G, we already have the E, T, A, B, or L. And we already have an E. Okay? So, what letters are in all 3 sets? All of them have an A. And all of them have an E. And I believe that's it, right? No C in this one, no D in this one, no G, no T, those aren't vowels. L, that's not a vowel. All right, so it's just A and E. Okay? And we could make a Venn diagram for that if we wanted to. So you can also use a Venn diagram to show the number of elements in the union or the intersection of sets. And this is actually where Venn diagrams get a little more useful. So let's make another nice diagram with my beautiful magic pen. That's going to make a nice perfect square. All right, so we have 2 things going on here. So of 500 commuters polled, some drive to work, some take public transportation, some do both. So there's 2 groups of people here. We have that group and, ooh, that group. I don't like that one. Let's do that again. Okay, that group. Okay, so the left group will say these are drive and these public. Okay, so 500 is my universe. Okay, so there's 500 people in this survey. Some drive to work, some take public transportation. 200 commuters drive to work. Okay, but I don't know whether to put them here is just driving or inside this little union of both. But this tells me 125 use both types of transportation. So that's a big clue right there. So I can put 125 in the both category. And now I know that 200 people drive. So in order for the driving circle to have only 200 people in it, that has 75. Now total, there are 500 commuters. So because of that, this whole thing has to add up to 500 commuters, which means that in this side right here, since I already have 200, this has to be 300. Now the question is how many commuters take public transportation? So that's everything in this circle. So it has to be 300, 125, so 425 take public trans. Good. Let's do one more gotta problem here. Okay. So again, let's make a nice Venn diagram. Okay. And let's see, 30 students in student government, 20 are honor students, 9 are officers. So there's 2 groups of people. So let's make 1 group, 2 groups. Okay. So now these are honor and these are officers. Okay. So out of the universe has 30 people in it. so that we can't have more than 30 people. There's only 30 people in the student government. 20 are honor students, but I'm not sure where to put them inside of this. And 9 are officers and honor students. So there's 9 people there, which makes 11 people there because these two numbers have to add up to 20 because there's 20 honor students. And then there are only 30 people total. So that means that there's 10 officers who are not honor students. Okay? So recall from lesson 3.6 that the graph of a compound inequality with the word and contains the overlap of the graph of the two inequalities that form the compound inequality. So you can think of the overlap as the intersection. Similarly, you can think of solutions to an or inequality as the union. Okay? So when we look at a situation like this, write the solutions that are either in the union or the intersection of the two sets. So because this is a less than inequality, we can write the compound inequality as 2x minus 1 is less than 3, and 2x minus 1 is greater than negative 3. Okay? And because both of these are an and inequality, we can rewrite this as negative 3 is less than 2x minus 1 and is less than positive 3. I can solve this by adding 1 to every side. That gives me negative 2 is less than 2x is less than 4. Divide everything by 2, and I get negative 1 is less than x is less than 2. So this tells me two things. It tells me that x is greater than negative 1 and x is less than 2. Okay? Which means that those two places, I want to know where they're both true. Okay, that's what the and means. So both of those have to be true. So that's going to be an intersection. So we can say that we have my two sets, x such that x is greater than negative 1, and my other set, which is x such that x is less than 2, and I want to find where these two sets intersect. Okay? Intersection and union would be or. Okay, so let's look at a couple guided problems that do both of these. So same thing for this one. I'm going to subtract 5 from every side in this inequality. So that's going to be 3 is less than x is less than 6. So when I solve this, I now have that x is greater than or equal to, greater than or equal to 3, and x is less than 6. So when I set this up, I can say x such that x is greater than or equal to 3, and wherever that intersects, x such that x is less than 6. Okay? And I know it's an intersection because this is a and inequality, as opposed to great or then is going to be an or inequality, right? See it? Great or less than. That might be pushing it a little bit, but that's one little trick to remember. I don't know if I mentioned that previously. So if you can't remember compound inequalities, less than, great or then. A little silly, but okay, so this is going to be a greater than, so we don't have a choice. We have to solve both of these separately. So we can't make one compound inequality. So this is going to be 4x minus 6 is greater than 14, or 4x minus 6 is less than negative 14. Add 6 to both sides here. 4x is greater than 20. Divide out the 4. So x is greater than 5. Add 6 to both sides here. And so now we have 14 minus 6 gives me 4x is less than negative 8. Divide out the 4, and we have x is less than negative 2. Okay? So when we do this, we always like to do the smaller set first. So this is the smaller number right here. So my answer is going to look like x such that x is less than negative 2, or, ugly or x such that x is greater than 5. Okay. So our lesson check, here are my 3 sets. Find union, intersection, intersection, union. So x union y. When I put those together, right, it's everything in x, everything is y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's it, because there's nothing else in x. Okay? X intersect y, however, is going to be all the stuff that they have in common. So that's going to be 2. They both have a 2, 4, 6, 8, and 10. However, x intersects z. X and z, if I look at x and z, that's 2, 4, 6, 8, 10, 1, 3, 5, 7, 9. Nothing in common. So for 3, the answer is going to be the empty set, the null set. All right? Okay? Y union z, take everything there, put it together with everything there, and we get the same thing because z is a subset of y. The answer is just y. In a survey of 80 people who use their cell phones to take pictures, play games, 49 take pictures, 35 play games, how many people only use their cell phone to play games? Let's see if we can get this. Let's make a nice, try to make it fit down here. Make our nice, there's 2 groups of people, okay? So the first people, cell phones to take pictures. This is games. So 49 take pictures and 35 take pictures and play games. So there's 35 people in here. Total, 49 people just take pictures. So we take the 49 minus the 35 to give me 14 people in there. There were 80 people in the survey. So we take the, whoops, we take 35, add it to the 14 to give me my 49, and then we just take 80 minus the 49 to give me 31 people in that group right there. So the question is, how many people only use the cell phone to play games? And that's these 31 people. So for the next one, number 6, suppose A and B are non-empty sets. Which set contains more elements? A union B or A intersect B? Unless they're both the same, A union B is going to have more elements because you're putting the 2 sets together. And A intersect B is only what they have in common. How are the unions and the intersections of sets different? The union of sets is the set that contains all the element of each set. The intersection of sets is the set that contains elements that are common to both. And finally, if X is an element, or A, true or false, if X is an element of set A and X is not an element of set B, then X is an element of A union B. That is true, because union, that means you're going to put them together. If X is not an element of A and X is an element of B, then it's in the intersection. That is false, because in order to be in the intersection, you have to be in both sets. Okay? So that's 3-8, union and intersection of sets.